Let's get started. On this class opener, we want to use this function g of x to answer the following. Let's first find the vertex of this g of x function. In order to do that, you need to know the formula. And when you use the formula, please use parentheses when you plug in your values. Your a value is -6, your b value is -24, your c value we don't really care about on this formula. So it's really a -24 divided by 2 times -6. So up on top, we end up with 24, and on the bottom we end up with -12, which means that our vertex x value really is -2. So again, the vertex is a coordinate xy, and the x value of the vertex is -2. We still need the y value. Whenever you have an x and you need the y, all you do is plug it in and plug in your x to find your y. So I don't normally do this, but I want to do it this time. I want to write function notation. See, g of x, most of the time we have it as y. But right here, I want to use that notation, g of x. I want to rewrite it as g of -2. Now, what does that mean? That's like me writing out a sentence that says, I'm about to plug in -2 in place of x into my g of x function. So that notation says that I'm going to be plugging in the -2 in place of x into the g of x function. So here we go, -6 x squared minus 24 x minus 25. So you're plugging in -2. Again, this is not really necessary. It's just more thorough, the notation. So let's work it out. What's -2 squared? That's 4. 4 times -6, that's -24. -24 times -2 is a positive 48 with the -25 at the very end. So doing the math, -24 plus 48, that's a positive 24. Positive 24, take away 25, that's going to be a -1. So your vertex x value was -2. You plugged it in, your vertex y value came out as a -1. That's your vertex. So finding the vertex is very important. It's the most important point of a parabola. It's either your highest point or your lowest point. That's where we begin graphing. If we were graphing this g of x function, I would find the vertex and I would plot my point, -2, -1. After that, what do I do if I were graphing? I would draw my axis of symmetry, right? So we're not actually graphing it right now, but we do need to state the axis of symmetry. And do you guys remember how to state the axis of symmetry? It's simply x equals the x value of your vertex, the x value of your vertex, which in this case is -2. So x equals -2, that will produce a vertical line crossing the x-axis at -2. So that's my equation for the axis of symmetry, x equals -2. Now, let's move on to the next one. It says max or min value. Well, the max or min value we could determine by analyzing and understanding the a value. What's the a value? -6. What does that mean? That it's opening down, right? The negative means that it's opening down. Positive means it's opening up. And the 6 just means that it gets narrower. It gets vertically stretched. So just for funsies here, let's do a little sketch right here on the side of an xy plane. And we know that the coordinate -1 or -2, -1 is right here. That's our vertex. And we know that the axis of symmetry would be the line going right through it. It's just a sketch. And we do know that this is opening down and it's pretty narrow. So opening down and pretty narrow, it's going to be something like that, right? So we do know that it's a max value. The max is, what is the max value? Y equals simply the y value of your vertex. So what happens to be the y value of your vertex? -1. So the max is y equals -1. Does this parabola even cross the x-axis? No. We just drew it right here. Here's a sketch of it. So when they ask us for the x-intercepts, well, we better know how to find the x-intercepts. How do we find the x-intercepts? You set y equal to 0 and solve. Okay. However, if I'm trying to find the actual location of where the parabola crosses the x-axis, what could we say? It does not cross x-axis. Okay. But just for the record, if I did want to find the x-intercepts of a parabola that did cross, well, you would set y equal to 0 and solve. So that means set this whole thing equal to 0. So you'd have a function like this, negative 6 x squared minus 24x minus 25. You would set that equal to 0 and you'd solve it. How would you solve that? By using the quadratic formula, right? But I already know, because I through my understanding of the a value, I already know that this opens down, and I already know the vertex is not going to cross. So if I did try to do the quadratic formula, I'd end up with imaginary values, right? You'd end up with a negative discriminant, which would cause imaginary values to surface. So the x-intercept, it does not cross the x-axis. How do we find the y-intercept?
Negative 25.
Yes, but how do we find that? Set x equal to 0 and solve. Okay, once again, to find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve. Now, finding the y-intercept on a standard form quadratic trinomial equation is the easiest thing in the world, because if you set these x's equal to 0, everything cancels out except for your c value. So finding the y-intercept of any standard form quadratic trinomial will simply always be your c value. So what's the y-intercept? Y-intercept is at 25, negative 25, right? So this parabola that opens down, that little sketch that we did, it's not going to cross the y till way down here at negative 25. Way down there. Make sense? Domain and range, that's pretty easy. The domain of any parabola is x equals all real numbers. The range is what? It's either y is greater than or equal to or less than or equal to the y value of your vertex. So it's obviously less than, it's opening down, and less than that y value of your vertex. What's the y value of your vertex? Negative 1, right? Looking at your vertex, y is negative 1. So y is less than or equal to negative 1. So put that as a range. Y is less than or equal to negative 1. And last but not least, number 7, describe the transformations from the original parent graph, f of x equals x squared, to the new g of x function above. So once again, just a little review. A parent graph, your y equals x squared, that's where your vertex is at the origin, and you use a pattern 1, 1, 2, 4, 3, 9, and you end up with this perfect parabola. Well, that's ugly. But anyway, that's your parent graph parabola. Any other parabola comes from this parent graph. So they want us to describe the transformations. So looking at our g of x function, you start analyzing the a value. What's the first type of transformation that happens from this blue parent graph parabola with that a value of being negative? What happens? It gets reflected over the x-axis. Write that down, please. Now, if you're trying to teach this to somebody that doesn't really know the math vocab, you would say that means that it opens down. The negative means that it opens down, right? But using the appropriate vocab, you would say it gets reflected over the x-axis, which means that you end up with, reflecting over the x-axis, it's the same parabola, but it just opens down instead of up. What's the next thing that happens? You're still with the a value. We already said negative is a reflection. What about the 6? What does the 6 do? It gets vertically stretched. Vertically stretched by a factor of 6. So what does that mean in English? If you're trying to explain to somebody that doesn't know the math vocab. Vertically stretched means that it gets narrower. Okay? So this green one's now narrower. That's what we call a vertical stretch. Now we also need to shift this around as your final step. So the final step is a shift, and of course you're going to use your h and k values to state that shift. So shifts where? Where does it shift? Right here it's at the origin, 0, 0. It already got reflected down to the red, and then it got vertically stretched to the green. But we need to move it where? Where's the vertex at of our g of x function? So based off of that vertex, -2, -1, you're going to shift it 2 to the left and 1 down. So that's a complete description from your original parent graph in blue to the final yellow narrow graph that is shifted 2 to the left and 1 down. So the original blue got reflected over the x-axis, giving you the red. Then it got vertically stretched, making it more narrow, giving you the green. And then it got shifted 2 to the left and 1 down, giving you the final product, the yellow. Okay. Those are the transformations. Those are all things we should know. So let's move on to today's notes. In today's notes, it's really not describing the actual transformations from the parent graph to the new graph, but it's actually changing a standard form equation to a vertex form equation. So we should all know that a standard form equation, the word form just means the way it's organized, the way it looks. So A, B, and C are all just numbers. The A value is the most important. It tells you if it opens up or if it opens down, if it's wide or if it's narrow. Same with this A value. The vertex form is amazing because not only do you have that A that tells you if it opens up or down, but it also tells you H and K, which is technically your vertex. That's why they call it vertex form. All you got to do is think opposite on H. In order to write an equation of a parabola in vertex form, you need 3 things. You need the A value, the H value, and the K value. So for example, if I told you, hey, A is 2, H is 3, K is 4, well then you could easily write your equation y equals 2x minus 3 squared plus 4. That's pretty straightforward, right? If you know A, H, and K, you could write it in vertex form. So keep that in mind. If you know A, H, and K, you're able to write your equation in vertex form. So it says right here, rewrite the following equations in vertex form. Right here we have a quadratic trinomial. And if only we knew our A value. Do we know our A value? What's the A value right there? It's 1. Remember the A value, it doesn't matter if your quadratic is in standard form, you can see the A value, or vertex form, you can see the A value. So you could always see the A value. The A value is the easiest to identify. So in this standard form equation, the A value is 1. Why? Because there's no number in front of the x squared. Now, how about H and K? Do they give us H and K? No. Could I find H and K? What is H and K? H and K is simply the vertex. Now, we don't see the vertex. It's not in vertex form. So let's find the vertex. How do you find the vertex? X equals negative B over 2 times A. Everybody should know that. So that's going to be negative parenthesis over 2 times parenthesis. Well, your B value is 10. Your A value is 1. Your C value we don't really care about on this formula. So the B value is 10. A value is 1. So we're going to end up with negative 10 divided by 2. So that is negative 5. So that's our vertex X value of negative 5. Now we still need the Y value. So how do I find the Y value? Thank you very much. Plug it back in. So I want to rewrite my function y equals x squared plus 10x plus 20. Notice that I put parentheses instead of x. Why is that? Because I want to plug in this x value of negative 5. So when I do the math here, negative 5 squared, that's 25. 10 times negative 5, that's negative 50, plus 20. If you do this with the calculator, 25 take away 50 is negative 25 plus 20. That's also negative 5. So the vertex y value is also negative 5. So now we found our vertex, ladies and gentlemen. The vertex is negative 5, 5. So technically, we now know our h value and our k value. So if I know my h value is negative 5 and my k value is negative 5, now I could plug it all into my vertex form y equals a parentheses x minus h squared plus k. That's what we want to write. We want to write an equation in vertex form. So I want to rewrite my equation here. Y equals a, which is 1. I don't need to put the 1. I could if I want to. X minus h, that'd be a minus negative 5, which ends up being a plus 5. Close parentheses squared plus k, and we know k is a negative 5. So ladies and gentlemen, we are done. There's your There's your vertex form equation. They're asking us to change it from standard form to vertex form. We just did it. Cool?
Yeah.
All right. The only way to get good at this is to practice, and it's not that difficult, guys. All you need is A, H, and K. Your A value is always going to be right there. Your H and K, after you find your vertex, is simply your X and Y from your vertex. Okie dokie. So let's try number 2. We need A, H, and K. Once we have A, H, and K, it'll be easy to go Y equals A parentheses X minus H close parentheses squared plus K. It'll be really easy to just plug it all into this once we know A, H, and K, and we'll be done. Okay, so what's the A value? 3. How do I find H and K? Find the vertex. So the B value is -6, the A value is 3, the C value we don't really care about. Let's find the vertex. X equals -b over 2 times A. That's negative parenthesis over 2 times parenthesis. That's a -6 for B. It's an A value of 3. It's going to be 6 over 6, which is 1. So the vertex has the X value of 1. I still need my Y value. How do I find it? Plugging it in. So here's my original equation. Y equals 3x squared minus 6x plus 5. Notice that I didn't put x's, I put parentheses. That way I could easily plug in the x value of 1. Doing the math, 1 squared is 1. We have 3 times 1, which is simply 3. 6 times 1 is simply 6 with the minus sign right between it, with the plus 5 at the very end. 3 take away 6 is -3, plus 5 is +2. So our vertex Y value is 2. Now we do know our H and our K. What's our H value? 1. What's our K value? 2. So now we just plug it all into the Y equals A parentheses X minus H squared plus K. So we have Y equals, the A value is 3, X minus H, which happens to be a 1, and then plus K, which happens to be a 2. Ta-da, we're done. There's your vertex form equation. Ladies and gentlemen, this equation right here, this vertex form quadratic equation, is the same exact thing as that standard form quadratic equation. If you graph this on a graphing calculator and graph this on a graphing calculator, you will end up with the identical parabola, because they're really the same thing, just a different form. Okay? Now, of course, there's many different ways of doing these, right? Like you could, let me just show you. Let me go back to number 1. Let me find this exact equation a different way. If I wanted to, I could complete the square. X squared plus 10x space plus 20. And we have a Y equals out here in the front. Now, this is a weird part that we have. Give me a second. The weird part is that we have a Y equals out here in the front, which means that to complete the square, you take half of B. What's half of B?
5.
And then we square it. What do we get? 25. So normally, if I add 25 here, I would have an equal sign over here, and then I would add 25 on the other side. But the problem is I have an equal sign with a Y right here. So you can't really do that. So right here, you add 25, and then you have to immediately subtract 25. I know that sounds really weird, adding 25 then subtracting 25, but the fact is right here we now have a perfect square quadratic trinomial. Completing the square will allow you to write it as a binomial squared with x right there, and then half of your b, which happens to be 5. Then the y comes down, the equals comes down, and the 20 take away 25, that's a -5. So there's our vertex form equation by completing the square. So we got the same exact answer as over here, but it's just a different way of doing it. So do you have to use completing the square? Absolutely not. As long as you remember that you need 3 things, A, H, and K, you'll be able to write it in vertex form. Like this one, I could see it that it is, you could at least, like if you want to try a different method, you could pull out a 2 and see what happens. See if that does anything. Inside you'd have x squared plus 6x plus 9. And actually this works out great because inside you have a blue perfect square quadratic trinomial. So you already have a perfect C value, which means that you'll be able to factor it to this, or like completing the square, you'll be able to write it as a binomial squared, x plus 3, with the 2 out in the front, which means that this is your equation now in vertex form. So if you want to try a different method, you could. Or you could always stick back with this fact. In order to write an equation in vertex form, you need an A, you need an H, and you need a K. So what is our A value? 2. What's our H and K value? We don't know until we find it. Let's find it using the vertex formula. X equals negative B over 2 times A. It's going to be negative parenthesis over 2 times parenthesis. The B value is 12, the A value is 2, so you have 12 right here, a 2 right there. That's negative 12 over 4, which is negative 3. So our vertex X value is negative 3. We still need the Y value by plugging it in. So let me rewrite the whole thing. Y equals 2 parentheses squared plus 12 parentheses plus 18. Let me plug in that negative 3 right in there. So when I do the math here, negative 3 squared, that's 9. 2 times 9 is 18. 12 times negative 3, that's negative 36, plus 18. And if you go from left to right, 18 take away 36, it's negative 18, plus 18 is 0. So the vertex Y value is 0. Which means now you know your H is negative 3 and your K is 0. H is negative 3, your K is 0. And now you could write it in vertex form, knowing your A, H, and K. So I'm showing you several different ways of doing these, but finding A, H, and K always works. Y equals 2 parentheses X minus H, which will be a minus 3, which is plus 3 squared, plus K, which is 0. You don't even need that at the very end. So there's your vertex form equation.
So if it's a negative number, just turn it into a positive?
When you plug it in, yeah. Or you could always do, you could always write it out. Y equals A, and then go X minus, and then whatever your H is, in this case it was negative 3, right? So if you do plug in the negative 3 right in there, the minus minus will change the plus plus. So it's up to you if you want to plug it in thinking opposite, or if you want to write it out minus minus and then change the plus plus. Anyway. Number 4, you could find the vertex to find your H and K, and you could already identify your A values too. Or a shortcut would be to understand that vertex form is Y equals A parentheses X minus H squared plus K. So in a sense, it kind of already is. You could look at it in standard form and say that your A value is 2, your B value is 0, and your C value is 2. Or you could say, you know what? There really is parentheses around the X. But what would the H be right in there? Yeah, so you'd have X minus 0, since there is nothing being subtracted in there, squared plus K, which is 2. So technically, this is your vertex form equation. So that's the shortest method of doing that one. But by recognizing that you could put parentheses around the X, that simply means that the H value is 0, K value is 2, the A value is 2. So there's your vertex form equation. Now, if you didn't want to do that, if you wanted to stick with the same method as always, you could do that as well. You could find your A value, which is 2, your H, and your K after finding your vertex. Right? So if you found your vertex, you would say X equals negative B over 2 times A, and the B value is 0. So 0 divided by any number is going to be 0. So your vertex X value is 0. Okay? And your K value would be what? Well, if you plug in 0 into here, 0 squared times 2, that's going to be 0. 0 plus 2, your K value will be 2. Right? So if you did plug in your 0 and got out a 2, that'd be your vertex, which means that your H is 0 and your K is 2, which when you plug it in, the H goes right here, the 0 goes right there, and the K goes right there, so you'd end up with the same thing. So on all of these, I've demonstrated different ways of doing it. A, H, and K always work. A, H, and K always work. So identify your A, identify your H and your K by finding the vertex, and then you could plug all that in. The A is right there, the H is right there, and the K is right there to get your vertex form equation. So we are going to be working on this worksheet 4.7 WSP. So we're not doing all of them. And you know what? I try to make space for your work, but you're probably not going to have enough space. You might have to rewrite this in your notebook. But we're doing 1 through 6. We're skipping 7, 8, 9. We're also skipping 12. So 1 through 6 is exactly what we just did on the notes. But 10 and 11, we should all know how to graph a parabola, whether it's in vertex form or in standard form, right? You could find the vertex using the vertex formula, but if it's already in vertex form, what is your vertex on number 10?
-1.
That's right. Think opposite on H, which would be a -3, and take K for what it is, which is a -1, right? So the vertex is -3, -1, which there's your vertex. Then you start by drawing an axis of symmetry right through the vertex. Then, of course, you could use the pattern because your A value is what? 1, 1, 2, 4, 3, 9, right? I mean, that's a pattern because your A value is 1. You're able to use the pattern 1, 1, 2, 4, 3, 9, right? So anyways, you should be able to do that. The answers are on the back so you could check it. But I do want to focus in on number 13 right now. 13, I've seen on the final exam, ladies and gentlemen. 13 and 14, or those types of questions, not those exact questions. But it says, write an equation for a parabola with the vertex 1, 3, and passes through -2, -15. So when they say write an equation, which form would you like to use? Especially if they give you vertex. Vertex form, right? So what is a vertex form equation? Y equals A parentheses X minus H close parentheses squared plus K. Now, what are the three things that we need to write this equation? A, H, and K. We need those three things. The question is, do they give us A? No, nowhere does it say that the A value is this. Nowhere do they give you an equation where you could actually look at the A value, the number in front of the X squared. It's not there. So we're kind of stuck, right? And in math, the beauty of math is you could take what they give you to find out what you don't know. Okay, so what are they giving us here? They're giving us a vertex, which is technically an H and a K value, right? But they're also giving us a point that the parabola passes through, a coordinate. So what is a coordinate really? It's an X and a Y value. So let's understand this, guys. We want Y equals A parentheses X minus H close parentheses squared plus K. But in order to write that, we need the A, the H, and the K, and we don't have it. But they do give us an H, a K, and they also give us an X and a Y. So we're going to plug in everything. We're going to plug in the H, the K, the X, and the Y to solve for A. Does that make sense? We're going to take what they give us to find out what we don't know. See, the only thing missing right now is this guy. Once I have the A value, I'll be able to write it because I already know they give us the vertex, the H and K value. So let's find that missing A value that we need. Okay? So instead of writing Y equals, I'm going to take the Y value that they give us right there, which is -15, right? So I'm going to write that out. Instead of Y equals, -15 equals. Y equals A, we don't know A, so let's keep the A right there. Parenthesis, X minus H. What is X? -2. Minus H, minus 1, close parenthesis squared, plus K. What is K? 3. Does everybody understand what I just did right there? I plugged in the H, the K, the X, and the Y all into this guy right here. And the only thing I have unknown is the A. So I'm plugging in what I don't know to find out what I need. Wait, I'm plugging in what I know to find out what I need. So let's do the math here. Let's solve for A. What's -2 minus 1? -3. -3 squared? 9. So I really have 9 times A out in the front plus 3 at the very end. So I really have 9A plus 3 equals -15. So let's solve for A. What do I do? Subtract 3, subtract 3. I will have, let me bring it up here, -18 equals 9A. What's my final step? Divide by 9, divide by 9. A equals -2. I now finally have my A value. So again, the three things that I need are A, H, and K. I just found out that my A value is -2. I know my H value is 1 and my K value is 3. So now I could actually write my vertex form equation. Y equals -2 for A, x minus h, which happens to be 1, close parentheses squared, plus k, which is plus the k value of 3. So this is my vertex form equation. So number 14 is done the same exact way. You're going to take what they give you to find out what you need. Okay, you need 3 things. You need the A, the H, and the K, but they only give you the H and the K. They give you the H value, they give you the K value, but they don't give you the A value. You need the A, the H, and the K. So far, all you know is that H is -3, K is 0, but you need that A value. So what are you going to do? You're going to plug in X, Y, H, and K to solve for A, and then you can write your equation. Good luck with that. This will be on the quiz Friday, and I did see one question like this on the final exam. So very important that you understand this. Now let's work on this for the rest of the class.